Okie dokie. Second example for this problem, I will try to work it out a bit faster. If you'd like more of a breakdown, please visit the other example I've worked out. All right, so in this problem, we're given a graph of biomass, and the goal is to identify its rate of change graph. So the breakdown is, or the approach is, we want to identify first where this original function has positive and negative slopes. So what I'm going to do is split up those different sections. So it starts off on the left side with just a baby positive slope, and then it changes around a little before t equals 2 to a negative slope until it hits about t equals 7, where it changes back to a positive slope. So wherever it has a positive slope on the original function, that should correspond to where the rate of change graph has or lies above the x-axis, or has positive y value. So which of these graphs start above the x-axis? It looks like A, B, barely, C, and then D. It looks like they all start above the x-axis, but which ones of them actually change to a negative slope, or change to below the x-axis, or have negative y values a little before t equals 2? It looks like this one, option A, B, C. Option A, B, and C are all super similar, but D is the only one that doesn't cross over into the negatives around t equals 2. It looks like it stays above the x-axis until about 8, and that's not what we're looking for. We're looking for it to change to below the x-axis, since the slope changes to negative much sooner. So between these three, they're just so similar, and we can see that all of them cross over from below the x-axis to above the x-axis around t equals 7, which is where we said the original function changes from negative to positive. So they're just all so similar. So probably the best way we can identify which is our correct answer is by finding the slope of the center, or more or less the center of the original biomass graph. We want to find the slope of basically this segment here in the middle. If we can do that, that'll help us identify which of these graphs is correct, because the slope value of the biomass graph should tell us what the y value is on the rate of change graphs down here. So our goal is to find the slope at t equals 4 approximately, and how we will do that is by finding the slope at 6, or finding the ordered pair at 6 and the ordered pair at 2. And if we find the slope between 2 and 6, that will be a great estimate for the slope right in between them at t equals 4. So let's break it down. We're going to find the ordered pair at 6 and at 2. So we have our x values. We just need to estimate the y values. It looks like at 6, we can claim that that y value is about 4. And then at 2, it's a little above 5.5, maybe 5.7. And now that we have two ordered pairs, we can find the slope between these 2 points. Again, the slope between 2 and 6 will be a great approximation for the slope at t equals 4, the slope of that major segment there. So finding the slope, we do y2, 5.7, minus y1, 4, and we divide this by the change in x value. So 2 minus 6. So up top, we get 1.7, and on the bottom, negative 4. So opening Desmos, we do 1.7 divided by negative 4, and we get about negative 0.425. So maybe negative 0.43. All right, so now, because this was the slope of the original graph at t equals 4, this value, negative 0.43, should correspond to the y value at t equals 4 on the answer choice graphs, on the rate of change graphs. So we're looking for at t equals 4, do we have a y value of approximately negative 0.43? So option A looks okay. It looks pretty good. It's just below negative 0.4, essentially. Let's look at option B. This is much further, below negative 0.4. It's after negative 0.5, and so this is almost negative 1 or so. And then option C at 4, we have, I don't know, maybe negative 0.3. It's kind of close, but it just doesn't seem right. It may even still be negative 0.2 something. So I think our best bet would be option A because it's the one that's closest to negative 0.4. So we break out the eraser and we see that A is in fact our answer. And so this is one of the more challenging versions of this problem, I will say, but essentially this method should help every time. The goal is really to find the slope in the middle of this main segment here. And we can find the slope, say at one point like 4, by finding the slope between 2 points left and right of it. In this case, we use 2 and 6. So hopefully this makes sense. If you have any questions, please let me know. If you have other versions of this problem that you're having trouble solving, please email them to me and I'd be happy to work them out and post them because this is one of the more challenging problems. Feel free to check out the first example I worked out if you'd just like to see more worked out.